The product of the roots of the equation is, well, what we can do initially is just factor. You can always multiply it all out and then factor, but I think it's perhaps quicker to factor immediately. And then if you do, you get x minus 4 plus x minus 6, like that. And then x minus 2, this is 2x minus 10. So from this we get x is equal to 2 or x is equal to 5. Those are the two roots. The product of those roots would be 2 times 5, which is 10. So number 14, the answer is 10, which is choice C. The number 503 is a prime number. How many positive integer factors of 2012 are there? Well, 2012 is equal to 4 times 503. So it's nice that they told you that's a prime number. Well, this is really just 2 times 503. And you can also write that as 2 to the power of 2 times 503 to the power of 1. Now, anytime you have this kind of a scenario, you have two choices. You can list them manually, and if there's not that many of them, it wouldn't take you that long. But if you had a large number like 7 times 503 to the power of 12, then obviously it would be very long. There's a trick. What you do is you take this number and you add 1 to it. So in this case, it'd be 1 like that. Then you take this one and you add 1 to it. And then you multiply them. So in this case, it would be 3 times 2, which is 6, right? So it would be very easy to do something like that with this technique. Manually, it would take forever. But let's do it manually also. I've got 6, so I've got to find 6 of these. Okay, no problem. One factor is just the number 1 itself. One factor is just 2012 itself. And then, of course, 2 is a factor. 4 is a factor. Right? 503 is a factor, and 503 times 2, which is 1006, is also a factor. So 1, 2, 3, 4, 5, 6. So with both techniques, that one and the manual one, I got 6 factors. So number 16, the answer is D. How many pairs of positive integers have the property that x over 4 equals the ratio 9 over y? X over 4 is equal to 9 over y. So cross multiply and you get xy is equal to 36. So we have to basically find what pairs give you a product of 36. And those two numbers, of course, have to be both integers. Well, let's see. 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 won't give you an integer, neither will, well, 6 will. 6 will give you, 7 and 8 won't, but 9, well, at this point, it's just reversals of what I've already written. 18, 2, 36, and 1. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 18, therefore, is D. On each spin of the spinner shown, the arrow is equally likely to stop on any one of those 4 numbers. Deanna spins the arrow on the spinner twice. She multiplies together the 2 numbers on which the arrow stops. Which product is most likely to occur? Well, the first time you spin it, it's got to have any of those 4 numbers, and the second time you spin it, again, it's going to have any of those 4 numbers. So there's a total of 4 times 4, 16 possible outcomes in terms of the 2 numbers that will result. So since there's 16, which isn't really that many, I can write them all out. So the first one, 1, 1, 1, then 1, 2, 3, 4. If the first time it lands on 2, the next time it could land on 1, 2, 3, 4. And similarly, right? 3, 3, 3, 3, 1, 2, 3, 4. And then the last one is 4, 4, 4, 4, 1, 2, 3, 4. So these are the outcomes, 16 of them. Now what I'm going to do is for each, write the product, because we're multiplying those 2 numbers and then looking at what do we get. So this is 1, 2, 3, 4. 2, 4, 6, 8. 3, 6, 9, 12. 4, 8, 12, and 16. Now, of these products, they're saying which one is the most common. Well, looking through this list, it looks like 4 appears 3 times, and I don't think any other product appears 3 times. A lot of them appear twice, but I think 4 is the only one that appears 3 times. So that's the one that's the product that's most likely to occur. So number 19, the answer is 4, which is B. The positive integer n has exactly 8 positive divisors, including 1 and n. 2 of these divisors are 14 and 21. What is the small sum of all 8 positive divisors of n? 2 of these divisors are 14 and 21. Well, 14 is 2 times 7, and 21 is 3 times 7. So that number n could be 2 times 3 times 7. Not necessarily, but it could be. That would mean 42. And I think 42 is n, because 42 has 8 divisors. How do I know that immediately without looking at what the divisors are? There's a little bit of a trick. You guys are in grade 7, so you may not know this. When you have a number broken down into its prime factors, look at the exponents. And then to figure out the number of divisors, you would actually just have to do the following. You take the first exponent, which in this case is 1, and add 1. Then multiply by, take the next exponent, which in this case is 1, add 1. And then you take the other exponent, which in this case again is 1, and add 1. This is 2 times 2 times 2, which is 8. That's how many divisors. And that will work with any scenario. And that's exactly what the question told me, that the number n has 8 divisors. So it's 42. Now all I have to do is just list them. The divisors of 42 would be 1, 2, 3, 7. 2 times 7, which is 14. 3 times 7, which is 21. And 2 times 3, which is 6. And then, of course, the whole thing, which would be 2 times 3 times 7, which is 42. These are the 8 divisors. And now I just have to add them because they want the sum. And when you add them all up, you get 96. So number 20, the answer is D. The expression is equal to 3 to the power of 2011 plus 3 to the power of 2011 all over 3 to the power of 2010 plus 3 to the power of 2012. Okay, we have to factor. The largest factor that exists in every expression is 3 to the power of 2010. If I do that on the top, I get 3 to the power of 1 plus 3 to the power of 1. In the denominator, if I factor out a 3 to the 210, I get a 1 plus 3 to the power of 2. These guys cancel, and all I'm left with is 3 plus 3 over 1 plus 9, and that is 6 over 10. In lowest terms, that is 3 over 5. Number 17, therefore, the answer is A. The value of root 81 is equal to root 81 is equal to 9. But 9 is not one of the answer choices. So we have to figure out which one it is. And of course, it's 3 squared. So number 11, the answer is B. The product of 3 different positive integers is 144. What is the maximum possible sum of these 3 integers? So A times B times C is equal to 144. And we want the maximum possible value of A plus B plus C. So if you fiddle around with this, you can say 1 times 2 times 72. If that is our A, B, and C, that would mean A plus B plus C would be 1 plus 2 plus 72. And that is 75. And that is the maximum that you can possibly make those 3 different integers. So number 15, the answer is B. The volume of a rectangular prism is 21. Its length, width, and height are all different positive integers. The sum of its length, width, and height is. All right, well, the volume is 21, and that's length times width times height. 21 can be broken up into 3 times 7. Okay. Well, it'd be nice if there was 3 numbers. There's only 2 here, 2 prime factors. Well, that's not a big problem. I can just stick a 1. And there we go. I've got 3 numbers, and they're all different, and they're all positive integers. So this is whatever order you want to put this in, width, length, height, doesn't really matter. They just want the sum. So the sum of L plus W plus H will be 1 plus 3 plus 7, and that is 11. So number 12, the answer is A. There are 2 ways of choosing 6 different numbers from the list 1 through 9, so that the product of the 6 numbers is a perfect square. Suppose that these 2 perfect squares are m squared and n squared, where m and n are positive integers and m does not equal n. What is the value of m plus n? Let's break up each of those numbers into its prime factors. So instead of 4, I write 2 times 2. 5, instead of 6, I write 2 times 3. 7, 8 is 2 times 2 times 2, and then 9 is 3 times 3. So we have to choose 6 numbers, and then in the end, that's got to be a perfect square. Okay, so this is going to be a little bit of an experimentation here. The first thing that we have to understand is that whenever you put numbers together, they've got to match up. So it's got to be 2 squared, or 2 to the 4th, or 3 squared, or 3 to the 4th, or like that. You can't have 2 by itself, or 2 to the power of 3. The exponents must be even. That's the only way you can get a perfect square. So that's very, very important to understand. So there's no way you can do that with the 5 and the 7, because there's only one 5 and there's only one 7. So 5 times 5 would not be possible. 7 times 7 would not be possible. So these 2 are duds. They're not going to help us. So we can only concentrate on 1, 2, 3, 4, 5, 6, 7. So we have to choose 6 from those 7. All right, let's experiment and see what we get. So I'm going to start off with this guy, 3 times 3. Okay, that's pretty good. Let's see here. I'll put in this 2 times 2. So far, I'm choosing perfect squares. Might as well put in this guy, 2 times 3. But then I've got to match them, remember? So I'll put a 2, and I'll put a 3, and then I'll stick in that 1. This gives me 3 to the power of 1, 2, 3, 4. And it gives me 2 to the power of 1, 2, 3, 4. Okay. When you do the math, that is actually equal to 36 squared. And therefore, that will be my m squared, where m is 36. All right, so I got one such value. Now we do the exact same thing again, and hopefully we will get another value. Let's use a different color. All right, so basically, it's kind of interesting that there's only 7 choices. 1, 2, 3, 4, 5, 6, 7, right? And in the first one here, I chose 6 of those 7. The only one I didn't choose was this guy. So obviously, in order to have a different number, I have to choose that one. So 2 times 2 times 2. Okay, so I took care of that one. Now, I guess, I've got to experiment, figure out, there's only one that I'm not going to choose, right? Because I have to choose 6 of the 7. Okay, well, let's see. If I'm wrong, I can always retrace my steps. Choose this guy. 2 times 3. I'll choose this guy. I'll choose that 3 in there. So my 3's match up, and so I'll do my 2's. So that's great. And then how many got? 2 more, right? Well, the only way is to put 2 times 2 and then to put the 1. So this was the only one not chosen this time. Okay, so this is 1, 2, 3, 4, 5, 6. 2 to the power of 6. 1, 2, 3, 4. 3 to the power of 4. Great. This is, if you do the math, 72 squared. So therefore my n is 72. So there we go. I got an M, I got an N. Now I just have to add them. And when you do, you get 108. So number 19, the answer is A.